Hi everybody, we're going to learn how to graph logarithms today, and we're going to do this using the previous video, so make sure you watch the video on inverse functions because that's where we introduced how to graph these. And I'm going to show you two different ways to graph them, but we're mainly going to be focusing on shifting logarithms. Now logarithms are important to graph because they come up a lot in pre-calculus and calculus. And I always find when I teach AP Calculus students who always forget what a graph of a logarithm looks like, and you do need to know the general shape. So the main focus of this video is just going to be practicing graphing different types of logarithms with different bases. What I want to do first is show you the answers to these problems here, which are at the end of the previous video on inverse functions. So here, 8 to the log base 8 of x. Since the bases are the same, they cancel. You're left with the argument of the logarithm, which is x. Here, the bases are the same. They cancel. You're left with negative 3x. Here, the bases are the same because remember, natural log has an invisible base of e that we don't write because it's so commonly used. The bases are the same. We're left with 20. Those are the most obvious ones. Now here, the bases aren't exactly the same. So what you have to do is rewrite this so the bases are the same. Now I can easily write 25 with a base of 5. That's just 5 squared. 5 squared to the x. Power to a power, you just multiply those together. So this is really just log base 5 of 5 to the 2x. You can drop parentheses then because you multiply 2 and x and you're left with 2x. Similarly, this one here, I can rewrite this as log base 3. 27 is 3 cubed. All to the x. Those cancel, you're left with 3x. And this one is, I can write 32 as 2 to the 5th. X, those will cancel, and I'm left with 5x. All right, so I just want to make sure you were okay on those answers. Let's start some graphing of logarithms. And the one I want to focus on first is log base 5 of x. So we have to remember logarithms have an asymptote. They have a vertical asymptote of x equals 0 by default. And the first way you can do this is just with a good old-fashioned table of values here. Now what you don't want to do is just go into autopilot mode. And normally we just do -1, -2, 0, 1, 2, numbers like this. Because if I try and evaluate some of these, like log base 5 of 2, I can't do that in my head. Like I have no idea what exponent 5 should have to become 2. 5 to what power equals 2? We don't know that. I mean, we could use a calculator, but the whole point is to do this by hand. So you cannot just autopilot, put down the typical input values that you normally would. What you have to do is think strategically here and think my base is 5. So what kind of x values can I easily evaluate? Well, I know what log base 5 of 5 is, so I can do an input value of 5. Log base 5 of 5, well, the base 5 needs an exponent of 1 to become 5. So I have 1. What about 25? I can do log base 5 of 25. That's 2. Can I do 1? Log base 5 of 1. 5 to what power is 1? Well, anything to the 0 power is 1. What if I try doing 0? Log base 5 of 0. 5 to what power is 0? Well, nothing. So 0 does not exist, and that's exactly why we have a vertical asymptote of x equals 0. Let's try and get different values. What if I do a fraction? What if I do 1/5? Log base 5 of 1/5. 5 to what power is 1/5? Well, that's 5 to the -1. So let's go ahead and plot these points here. 0 does not exist. I have 1, 0, 1, 2, 3, 4, 5, I have 5, 1. 25, 2, I just can't really plot that. And I have 1/5 -1. Okay, so let's go ahead and plot these. And you could do more points, like you could do 1 over 25. 1 over 25 would be -2. But it's really hard to plot 1/25 down at -2. Another way, let's say you're struggling to find some good input values. What you could do is plot the inverse of this. And the inverse of this is the exponential with the same base. So So instead of log base 5 of x, it'd be 5 to the x. And it's really easy to plot 5 to the x. Here, I can just do any values I want. 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. Well, 3 isn't going to make sense to plot. Let's do -1. 5 to the -1 is 1/5. Now you should notice these are just the opposite ordered pairs. So I have 0, 1, I have 1, 5, I have -1, 1/5. So what you could do, instead of worrying about this table, you could just do the inverse first, get those ordered pairs, and then swap the ordered pairs. So it's like, oh, okay, I know it's 0, 1, so let me plot 1, 0 for the logarithm. So there's two methods of doing this. Okay, so now let's get to the part we actually want, and the part we actually want is to do transformations. So what I'm really interested in is graphing y equals log base 5 of x plus 3. And remembering our transformations, if the shift is inside the parentheses with the x or in the exponent with the x, however it is written, if it's with the x, that is left and right, and do the opposite. So plus 3 would move in the negative direction. That would be left 3 units. So I'm just going to take every single ordered pair, 1, 2, 3, and go left 3. So go ahead and plot that out with me here. And I'm going to move my vertical asymptote to -3 as well. X equals -3 is our VA. And this point is going to be the trickiest to plot. Instead of 1/5, I'm going to move this over here. That would be what, -2 4/5? Okay, and then it's kind of hard to do this on the computer. Hopefully yours turns out better than mine. Slowly going to grow. Remember, logarithms have the slowest growth. And this should not touch the vertical asymptote. You can't really tell based on mine, but make sure it's not touching the vertical asymptote. Okay, let's try a couple more. What if I have log base 5 of x plus 2 and y equals log base 5 of x minus 1 minus 3? All right, this plus 2 is not in parentheses with the x's at the end. So that means up and down, you do what it says. I'm going to go up 2. So let's take the points we started with here. So I know what to shift. I had 1/5 -1. I had 1, 0. I had 5, 1. So I'm shifting those points up 2 units. So 1, 2, 1, 2. It's really not too bad once you get the hang of it. Getting the initial points of the original one is the hardest part. So my graph, don't just make it look like a square root graph. Some people stop here. They don't do the downward curve. You need to, and although it's the hardest part to graph, you need to include that downward curve showing that it goes down forever towards negative infinity. And then the last one, I am moving down 3 and opposite here, right 1. So let's start with our original points, like so. That's my just log base 5 of x. I had a vertical asymptote of 0. What I want to do is I'm going to move right 1. So that's going to move my vertical asymptote over here to be x equals 1. Shifting down 3 doesn't affect my vertical asymptote. So let's take each point and go right 1, 1, 2, 3, down 3. Right 1, 1, 2, 3. And then right 1, 1, 2, 3. So that's how you can graph a logarithm using shifts. I'm going to do just one other one with you just to make sure you're going to be totally fine. And I hope when you graph these are smoother than mine. Mine are a little bit jagged here. Let's do one with a different base just to make sure you're going to be okay figuring out the initial points here, because you want to be able to do it ideally this way without having to graph the exponential one first. It's just more efficient, and it shows that you really can think in terms of logarithms, not relying on exponents. So I'm going to graph log base 4 of x, but then the one I'm really interested in, I guess this is number 4. This says log base 4. It's really messy. What I'm really interested in is log base 4 of x plus 2 minus 1. Just so we're on the same page, I will be shifting left 2 and down 1. Let's do a table of values for log base 4 of x. And let's think, ideally you would pause the video now and try and come up with some inputs that make sense to evaluate this logarithm. Don't just go like 1, 2, 3, 4, 5. You want to be strategic here. And try and come up with a table of values on your own and see if we agree. Go ahead and pause and try that. The ones that I would do are log base 4 of 4, which is 1. I would try using 1. Log base 4 of 1 is 0. I would try 1/4. Log base 4 of 1/4 is -1. 16 could make sense. Log base 4 of 16 is 2. The problem is I can't go out to 16 on my x-axis, so that's why it's actually not that helpful. Where am I? 1/4, -1. So the logarithm, all the graphs really look similar. Notice this one looks almost exactly the same, except instead of going out to 5/1, I'm going out to 4/1. So let me graph this here. Oops. And in order to do this one, I'm just going to go left 2, down 1. Left 2, that's going to move my vertical asymptote. Left 2 units. So now I'm at x equals -2. X equals -2 instead of x equals 0. Okay, left 2, down 1. Left 2, down 1. And left 2, down 1. And there you go. So you always have this really sharp increase immediately, almost leveling off to the right. All right, actually, I did want to do one more here. Just kidding. I know I said one more before, but it's okay. Log base 6 of x minus 4 plus 2. Y equals log base 6 of x. That's my base one, my parent function. And then here is the one I'm really interested in. So again, it'd be really beneficial for you if you paused and came up with the points on your own, and then came back and see if you agreed. So I'm going to quickly do the original one. 1/6 -1. I start with my standard vertical asymptote of 0. And I'm really close to the vertical asymptote, not touching it. Here we go. And here, think, how am I shifting here? This is right 4, up 2. So I have a new vertical asymptote at x equals 4. Okay, 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. And 1, 2, 3, 4, up 2. There you go. Don't forget the downward part. All right, I have some for you to try, and then add these on at the end of your video notes and upload everything. So we have several you tries for you. Number 1, log base 4 of x. Number 2, log base 2 of x minus 3. Number 3, log base 3 of x plus 4. Number 4, is there a number 4? I thought there was a number 4. There we go. Y equals log base 7 x minus 2 plus 3. Okay, cool. So graph the unshifted and shifted when you do these. This one, there is no shift at all. It's just the original. So that's the only one you're going to have just one graph. All these you should have the unshifted and then the shifted. Okay, cool. Have fun graphing.